Hi, this is Mr. Hodgen, and this is the Algebra 1 review for our order of operations and solving equations quiz. All right, important to make sure that by the end of this review, you can do each of these problems on your own and understand how to show all the work. All right, let's get started with number 1, doing order of operations. So let's start off with the parentheses first. I'm going to rewrite the whole problem and simplify only one step per line. That way we don't have a chance of making a mistake. So we did the parentheses, then we'll do the exponents next. So let's do exponents. 1 to the second power is just 1. Okay. Now we'll do some multiplying. 4 times 1 is just 4. We'll have some more parentheses here, which is subtraction. We don't have any division, so we'll go straight to subtraction for these parentheses. 9 minus 4 is 5. And lastly, we can multiply and get 15. For number 2, very similar. Just treat the top and the bottom, the numerator and denominator, as separate problems, and then at the very end, simplify if possible. So on the top here, 9 minus 5 is just 4. On the bottom, we'll have 2 plus 12, right, which is 4 over 14, which reduces to 2 over 7 after you divide top and bottom by 2. Right, that's how we get 2 over 7. Number 3 is this, go ahead and do a check for this problem, see if the solution is a solution or not a solution. So we're going to plug in 4 over 5 back into the original problem. So we got 5 over 3 times 4 over 5 minus 2 over 3, and we're checking to see whether or not this is equal to 2. So if it is equal to 2 on the left side, it will be a solution. 4 over 5 is a solution. If this on the left side does not come out to 2, then you know 4 over 5 is not the correct answer. All right, so let's multiply top times top, or we can cross cancel these 5s actually. That might be faster. 3 and 4 do not cross cancel, so I have 4 over 3 minus 2 over 3, and we already have this common denominator of 3, so 4 minus 2 is just 2. So we have 2 over 3, and that does not equal 2. Therefore, this 4 over 5 is not a solution. And if you'd like, you could go through this problem on the left and see where the error is. But for sure, that's not the correct answer. All right, go down and let's solve each equation and then do a check. So show the algebra, very important, show the algebra, both sides. Right, so yeah, n equals 60, and then just prove it with order of operations, and you know you're finished when you have, just like on number 3, the same number on both sides. Number 5, let's rewrite this in a little bit better format. I'm going to put a 1 up here. I'm going to move the x out of the way. I'm going to move this negative to the top, just to get it in the right format. That's a little bit easier to solve. So now I have negative 1 over 5, and then x follows. And then it's a little bit easier to multiply by the reciprocal now on both sides. We got 5 over negative 1, 5 over negative 1. Negative 1's cancel, equal 1. 5's cancel, equal 1. So we have 1x equals 20 times 5, which is 100, divided by negative 1. So negative 100. And then show the check. So we'll have negative 100 over 5. Does that equal 20? And sure enough, these two negatives cancel out and make a positive. And 100 divided by 5 is 20. So we have our correct answer of negative 100. Look at 6 and 7. We have a double sign here, so let's take care of that first. So we'll have 7 equals 8, and then 2 negatives will make a positive. And then we can do the algebra of subtracting 8 on both sides. So we get 0 here. X equals 7 minus 8 is negative 1. And do a check, make sure it's correct. So negative 1 minus a negative 8. Negative 1 plus 8. 2 negatives make a positive once again. And then 8 minus 1 is 7. So there we go. We have a two-step on number 7. So start with the addition subtraction of subtracting 2 on both sides, and then we can divide by 5 on both sides. Start by subtracting 2 on both sides. 30 equals 5 times what? So 5 times what is 30? Divide both sides by 5. We'll get 6 equals x. And we can plug it back in and verify. So 32 should equal 2 plus 5 times 6. And looks like 5 times 6 is 30, and then 2 plus 30 is 32. I have to box my answer here. There we go. All right, let's flip it over to the back. Same idea, just solving equations and checking your answer. So this is an addition problem, so that means we need to do the opposite of subtraction. So I'm going to subtract 1/2. It might be tempting to do a reciprocal here, but that's only for multiplication. This is clearly addition, so we must subtract. So subtract 1/2 on both sides. We'll get y equals, see, 19 minus 1, 18 over 2. But then always reduce fractions. 18 divided by 2 is 9. Okay, and plug it back in. So 9 plus 1/2. Does that equal 19 halves? A couple ways of doing this. We can convert this to a common denominator. Right now it's 1, so if we multiply top and bottom by 2, we'll have 18 over 2 plus 1 over 2. So 19 over 2 equals 19 over 2. Let's see here. Number 9, we're going to start with the addition subtraction first. Let's add 1 to both sides. So we got 1/4 of what number is 8? And then solve by taking the reciprocal of both sides, multiplying by both sides. 4's cancel out. We'll have 1x equals 32. And then plug it back in. 1/4 of 32 minus 1 equals 7. 1/4 of 32, or 32 divided by 4, is 8. And then 8 minus 1 is 7. We have a one-step equation with just multiplication, so I am going to multiply by the reciprocal here on the side of the variable. Show that those 9's equal 1 and those 4's divided and equal 1. Negative 8 times 9 is negative 72 over 4, right? Then you have to reduce, or you can just maybe do some cross-canceling to get some big numbers. 4 goes into 8 2 times, so we have negative 2 times 9, which is negative 18. That might be a little bit easier. Okay, check it out. We got 4 9ths times negative 18. Does that equal negative 8? Okay. And sure enough, 9 goes into negative 18, negative 2 times. 4 times negative 2 is negative 8. Let's go ahead and add 2/3 of both sides to solve this one-step equation. We have y equals, oh, we don't have common denominators, do we? So we have to maybe do a little side work or use a calculator here. We need these to be both common denominator of 6. That's the smallest number 2 and 3 go into. So I'm going to multiply this one by 2, top and bottom, this one by 3, top and bottom. So I'll have 6 over 6. There we go. So 3 times negative 15 is, negative 5 is negative 15. 2 times 2 is 4. And we'll have, let's see, negative 15 plus 4 is negative 11 over 6. There we go. And we can do a check. Negative 11 over 6 minus 2/3. Does that equal negative 5 over 2? Again, we need common denominators of 6. So we'll have negative 11 over 6 minus 4 over 6 equals times what, 3? Negative 15 over 6. Yeah, and sure enough, negative 11 minus 4 is negative 15. So we will get negative 15 over 6 equals negative 15 over 6. Okay, getting towards the end here. More practice, doing 2 steps. So variables on the right this time. Let's start with the addition part here by subtracting, making it 0. And negative 3 and negative 5 is negative 8. And a sixth of what number is negative 8? So let's multiply by the reciprocal, 6 over 1. So 6's cancel. We have x left over. 6 times negative 8 is negative 48. Plug that back in. Negative 3 equals 1/6 of negative 48 plus 5. 1/6 of 48 would be just 48 divided by 6, which is negative 8. And negative 8 plus 5 is negative 3. There we go. We got a, let's see here, variable on the right again on number 13 with a negative 7. So this time we'll start by adding, doing the opposite. So there we go. That's 0. 4 times what is going to be negative 23 plus 7. Let's see here. That's going to be negative 16. And then we can divide both sides by 4. Negative 4 will equal x, and we can verify that. So does negative 23 equal 4 times negative 4 minus 7? All right, so we'll get negative 16 minus 7, and negative 16 minus 7 is negative 23. So there we go. All right, lastly, we have 2 problems here with some negatives, so just watch out for negatives. So we have, let's see, negative 2/3 times what number will be negative 12? So let's assume the negative here is really on the top. So it's negative 2, and then multiply by the reciprocal, which would be 3 over negative 2 both sides. 3 over negative 2 both sides. Cancel our diagonals out. We'll have negative 12 times 3, which is negative 36, divided by negative 2, which is negative 8 or 18. Or we can say that -2 goes into -12 6 times, and then 6 times 3 is also 18. So we got -2/3 times 18 should equal -12. So 3 goes into 18 6 times, and sure enough, does equal -12. Lastly, we have a double negative here. So let's rewrite this first as a positive, and then we can solve. Okay. 5.9 minus 3.4 will give you 2.5. So we have 5.9 equals 2.5 minus a -3.4. And for the last time, the two negatives will make a positive. So it's really 2.5 plus 3.4, which is 5.9. Okay, so that was a pretty accelerated pace on which I did each problem. You want to keep redoing each of these problems until you can do these at a similar pace and still show all the work without skipping anything. Remember, the most important steps on algebra homeworks and algebra quizzes and algebra tests is showing the algebra. What did you do to both sides to get your answer? Okay, that's the most important part. Of course, the answer itself is important as well as the check, but how you're getting the answer is the primary question in algebra. All right, good luck, and we'll hope you do well on the quiz.